In this lesson, we'll introduce technical trading indicators that are fundamental to algorithmic trading. We'll start with loading the data, then we'll visualize various key attributes of the data such as density plots and comparison with normal distribution. We'll compute and examine various moving average indicators such as simple moving average indicators and exponential moving average indicators. And we'll also see how to interpret them. We'll also visualize and examine momentum indicators such as Bollinger Bands, MACD, that is moving average convergence divergence indicator, relative strength indicator. We'll also construct complex technical charts with the help of quant mode package and TTR package. The implementation will be done with the help of R programming. Dear learners, in this video, we'll see how to load the relevant libraries and download the data. First, we'll set the correct working directory. This is a very important step. We should choose the working directory where all the relevant data and files are loaded. Once I select the working directory, notice a command has appeared in my console. For future purposes, I will keep this command on my script file so that even if I forget where my data and relevant files were there, I can still access it through my script file. Let us start the session by loading the relevant working libraries. So first, I'll use this library command. First is TTR, which is very important library for running technical trading rules. Then zoo. This zoo is important for running time series packages. Another one is XTS. Then you have another very important library, which is quant mode. Next, you have library car. Another is performance analytics. One more interesting library is for each. Next, we have library financial instrument, library tidyverse, library tidy quant, which is also very important to work with quantitative techniques in R. With this, we have completed loading the relevant libraries. In the next video, we'll discuss how to download the data and visualize the data. In the previous video, we loaded the relevant libraries. Now in this video, we'll download the data. We'll download the data and visualize the data. So first, let us name this variable as Amazon. We are going to download the Amazon stock prices. We'll use this very important useful function get symbols. In the get symbols package, get symbols function, we'll provide the ticker for Amazon, which is AMZN. Next, we need to provide the period from 2000, maybe December 31st, 2010 to, we'll use maybe 2020, and again December 31st. So this will be the period. Now you need to provide this auto.assign as false, so the data will be downloaded in Amazon variable. In order to test whether the data has been downloaded or not, you can check the head of the data. Yes, so it starts from December 2010, and let's see the tail of the data. Also, there are chances that some observations are not available. You can see it has downloaded the open, high, low, close, volume and adjusted prices. There are chances that there are some observations not available. So you can use this na.omit to remove some of the missing observations that may be or may not be there. So now we have removed if there were any na not available observations. Next we'll see the dimensions, how many observations have been taken or that we can see 2517 rows and 6 columns that are variables that we just discussed. So these are our relevant variables in the data, and let us try to visualize the data first and see what we find. So to start with the visualization of downloaded data, first and foremost let me create 4 plots. So we'll have 4 plots. I'll use this mfro equal to c. First I'll put 1 comma 1, so I'll only plot the closing prices. Let's see how it works. Plot, then I'll use this Amazon, and since I want to choose the closing prices, I'll select the closing prices. Let me enlarge the plotting window so that I get a proper plot. You can see the plot, a very nicely plotted chart here. This is because it is automatically using the time series properties of the data, and therefore we are getting this kind of plot. Next, I want to plot and visualize the weekly, monthly, quarterly and annual data, let's say. So I want to convert the series, and before that I'll create, now earlier I used the 1 comma 1 cross 1 single plot window. I'll slightly modify this chart to have 2 cross 2 kind of, as you can see 2 comma 2, which means 2 cross 2. So 4 windows will appear in the plotting, and I want to plot weekly. So first I'll create this Amazon weekly variable, which is equal to 2 dot, this is a very useful function, 2 dot weekly, which I'll use, and this is part of that XTS package that we loaded in our library. I'll supply the data, so it will create the weekly series. Let me also create monthly series, which is 2 dot monthly. Similarly, let me create quarterly series, which is 2 dot quarterly. Then yearly series, which is 2 dot yearly Amazon. So I have created all the 4 series, aggregated the sort of daily series into weekly, monthly, quarterly and annual series. Now I'll go ahead with plotting them. I'll start with plotting them. I'll use again the same plot command, and first Amazon weekly, let's plot it. So I'll get a plot window. As you can see, I need to first, okay, so now it will work. First is weekly, then I'll plot monthly, then I'll use quarterly, and lastly I'll use the annual. As you can see, as I keep on increasing the frequency, the plot is becoming smoother and smoother. This is so because as you increase the frequency of the data, in the sense you move from weekly to monthly, the noise component declines and a more smoother plot appears. As you can see here, the 4 plot windows. I'll zoom in front of you. You can zoom it like this. Also, you may not be very happy with the same color coding scheme. So if you want, you can have a slightly different color. For example, you can put the first graph into red, maybe second into blue, maybe third into green. So I can choose the color coding that I want, and the last one maybe into black. Also, if you are not happy with the line width, you can increase the line width. For example, you can put this line width argument LWD equal to 2. So this will help you increase the width of the line that you have plotted. So again, for all the plots, I'll give line width equal to 2. So a slightly more darker shade of line is plotted. Sometimes when it is too thin, it does not appear very good. So I'm just increasing the thickness of the line. So probably it may help with this LWD equal to 2 command. So with this, we have visualized the data in this video. for different series. We aggregated the data into weekly, monthly, annual, and quarterly from the daily series. Then we visualized the data. We also saw how to change the colors or change the line width. In the next video, we'll convert our data into OHLC data, which we'll use into further advanced technical analysis. In the previous video, we visualized the closing price data. In this video, we'll convert the overall series into OHLC series, that is open, low, high, close prices and volume. So we'll have OHLC volume data, and we'll also try to see how it helps in visualization of the data and some other processing as well. So first and foremost, because we are creating this OHLC data, I need to remove the last adjusted price because we only need open, low, high, close prices along with volume. So let us work with monthly data. Slightly less noisy, which is a good trade-off between less noise and higher frequency. So we'll work with the monthly series, and I'll remove with this simple command, I'll remove the 6th column, which is adjusted prices. So if I show you the head of the data now, you'll notice that there is no adjusted price column. Now with this data, let's call it OHLC, Amazon OHLC, and this is Amazon OHLC. What I'll do is I will use this as.quantmode OHLC command to convert the data into OHLC. I'll supply the OHLC price series here. I'll give the column names as I wish, maybe open, so I'll adjust the width a little bit. So open, then I know after open I have the high, then I have the low prices, then I have the close price series. Notice that I'm feeding these arguments in quotes. So when you are setting the name of something, it is customary to put it in quotes, then the volume. So I'm giving argument by argument. Now my arguments are done. Let me completely close this window. So also one thing I forgot, I should have added this. Now the argument is complete. So if I run this, I get my Amazon OHLC data in required format. Let's see what exactly I have created. So I'll use the head command to see some of the initial headings. So it is OHLC open low as we wanted, and now the date is a separate identifier. So now you would see that I would use an advanced command, chart series. It's a very powerful command. So in subsequent sections and videos, we'll see the advanced version of this part of quant mode package. So in this chart series function, there's a lot of amazing visual properties of stock market prices. So let's say I just apply OHLC, and you will see I'll give a theme white. You can change the theme also. So I'll give a theme of white. There are a lot of arguments as we'll explore later on in subsequent videos. And I give name of the chart. Let me supply the name as Amazon OHLC. And you will notice I'll slightly, in order to enlarge the plot window, because then the plot will look good, I'll now run this command, and you notice such a nice wonderful diagram has appeared where I can see the candlestick movement, sort of candles of prices and then volume below. So it's a very nice looking diagram. In fact, so for example, let's say instead of white, if you wanted to change the color, you can, there's another theme available to you. You can use the black theme, and it looks like this. In addition, you can change the plot type also, but we'll explore that in subsequent videos. So till now, we have understood how to create OHLC series from the open, low, high, close and volume data and visualize it using chart series plot in a very nice manner. In subsequent videos, we'll download all the relevant series that are needed. For example, we'll download Amazon, Nifty, Apple, Google data, and then we'll try to do some kind of technical analysis and visualization of the complete data. In this video, we'll download the relevant data series. We'll download from Yahoo Finance, we'll download data for Amazon, Nifty 50, Google and Apple, and then further create the closing price series using the data. So first and foremost, let's name Amazon and use this again, the same get symbols command. Use Amazon from 2010 12/31 up to 2020 12 December 31, and again we need to set this auto.assign as false. So this will help us get the Amazon data. Similar to Amazon data, we'll just now not repeat the code. All we have to do is just replace symbols. For example, for Nifty the symbol is NSCI, so we'll just change the symbol to #NSCI, which is the Nifty symbol. Download the data. Next we'll compute Google, so let's call it Google, and we'll use its symbol GOOG to get the GOOG Google data, and lastly we'll get the Apple data. So we'll use the Apple data. So we have all the data series. Now that we have downloaded all the data series, the next step is to extract the closing prices from these series. So we'll create a new data called closing, and in this closing variable we'll cbind, we'll use the cbind zoo wrapper, cbind and dollar closing prices. Similarly we'll use the closing prices of Nifty closing price. Next we have Google, we'll use the Google close. Lastly we have Apple, and we'll use Apple close. Let us run this command and see if we have obtained all the relevant series in the closing. Yes, we have, and they have this data properties attached to them, which comes from the original data that we downloaded. The next step is to clean the data. There may be possibly some not available NA observations, so we'll use the regular procedure of NA.omit and we'll run it. So even if there were some NA observations, they'll be removed. Now the dimension is 2383. Again the same 4 data variables, that is 4 stocks, and 2383 observations from 2010 December 31st to 2020 December 31st. The next step is to create the return variable, and we'll preferably use the log return variable. So let me show you how to create this return variable. All we need to do is Amazon. Let's create Amazon return, and we'll use the daily return version. So daily return formula, Amazon dollar closing prices. We'll select the type as log, so the log returns are created. Similar to this formula, write the heading also. Better to create closing price series, and now we are trying to create returns from closing prices. So we have created the returns for Amazon. Next we create returns for Nifty. All we need to do is give here Nifty and then select the closing prices for Nifty, which is NSCI close. So this is next. Next I need to have Google returns, so we'll use Google prices and closing prices rather. So I'll use the Google closing prices. Lastly we have Apple, so we'll use the Apple closing prices, and we'll create the Apple closing price series log data. So this is created. The next step is to bind all the series to create a consolidated return series by using this cbind.zoo command, and here I'll bind so Amazon return, then I'll use Nifty return, then Google return and Apple return. So this will be our return series. Also, if you want to check you have created the return variable correctly, you can just see the head of this return variable. Sometimes you want to use a simpler procedure using this apply functions. Apply functions are very useful. Let me show you. I could have simply applied this as apply to closing prices and define the function. Show you how to use these apply functions. I can simply use the closing series that I have created. Now I will just define the relevant function, which is difflog. Difflog is like first you take the log and then take the difference, which is again the log return version. So I can apply that, and with this also I can compute the returns in a rather simple and more parsimonious simple line of codes. I can create the return function. So that is also there. You can create that. So now we have created our return variable in this video. From next video onwards, we'll try to examine the properties of returns and try to visualize them for their various attributes. In this video, we'll plot the density plot for all the 4 securities and visualize it to see how they are distributed. So first we'll plot on a single window using this P equal to mfro. So this ensures that we have one plotting window on our plot chart. Then let us use this density plot command. This is a very useful command in our package. All I need to provide is the return data. Return, we have already created our return data, so we'll use this daily return for Amazons, and let us give a line width of 2. We already know these arguments. Color is red, and a central heading that this is a, to tell that this is a density plot. Also, let us give some argument. Let us have y-axis. Let's keep the y-axis empty and also the x-axis empty. So let's start plotting this. So as a first step, we'll plot this graph. It is nice appearing plot has appeared here. Now we'll one by one we'll add the lines, other graph through this lines command. So first density, and the first is Nifty. We'll add the Nifty. Again we will add the line color as blue. We'll use the line color, line width of 2 and line color as blue again. So this is our next plot. So we'll add the Nifty plot. Notice that Nifty has crossed the extreme limit, so we need to slightly increase our Y limit. It seems slightly lower than desired, so I'll increase the limit. As you can see, I'm using this Y lim in the main plot, and I'll redraw my plot. So Y lim I have increased to 50. Let me redraw. So you can see now my y-axis has enlarged, so now I can nicely plot my chart. Let me add some other. So I'll just copy paste rather than writing afresh. So now I have added Nifty. So next I'll add Google. So let me add the Google. Yep, so Google with a color of green. Probably I'll put a green color. Let's see if it works. Yes, it does. And the last one that I'm going to add is Apple, and I'll probably use a different color here. Apple, maybe black, and run it. So as you can see, across all the graph I can compare their distribution. So we can see that the blue one, which is Nifty, has the highest peakness as compared to the red one, which is Amazon, which has the lowest peakness, and others fall in between. Now a more appropriate comparison, also I can probably improve this graph. Notice probably I can add a nice legend to it, so it looks more publishable. So let's add legend, and top right and top left windows are open, so rather I'll use a top right. Maybe you can use top left also, there are various options, and provide the legend Amazon, then Nifty, and then Google, and lastly I'll use Apple. So these will be my tickers, and the next set of command I'll give the color fill. So fill will tell R that sort of legend are in this color, and green. Now, so this is my legend that I have used. So 4 colors I have added. Let me see if they work. So let me run the command, and so I need to do some minor adjustments. For example, I forgot to add a C here, so it didn't take the color. Now you can see. Also, I generally prefer to write it as call, so you will notice some additional changes will happen as soon as I run this extra call function. It will add some nice lines here maybe. Okay, so probably even without it, it works fine. So I'll remove this. So even without it, you can have at least some legends you can have. You can visualize one. So you can have the nice plot where you can have the, let me start afresh. So you can see here the plot is there. So you can have a nice legend here, and along with the graphs, a nice publishable graph. So now that we have plotted our density plot, in the next video we'll compare these plots with the density plot of a normal distribution, which will give probably more solid inferences. In this video, we'll compare the density of individual stock returns with normal returns. So we'll compare with the normal return density. So first, let me create 4 plotting windows with this mfro equal to C2, 2 command. There'll be 4 plotting windows in the graphic plot tab, as we'll see shortly. First, we'll superimpose with the normal and Amazon. Let's see how it is done. So first we plot the density plot of daily returns of Amazon with a line width of 2, as we have already seen these parameters, how to supply them. Red color. I'll use a central heading which is main equal to density plot Amazon versus normal in black. So we'll keep the normal distribution in black. Now first I'll show that there's nothing on y-axis, so y-axis name empty, axis label as empty, then x label as empty, and then with this, the next thing I need to supply, let me see if this command works. So it helps me getting the red Amazon density plot for returns. Then let me generate a new variable norm which contains a specific normal distribution with 10,000 observations. Let's see, n equal to 10,000 with the mean which is precisely equal to the mean of Amazon returns. And also its standard deviation as standard deviation of Amazon returns. So we plot a graph where the distribution exactly with the same mean, but it will be the standard normal distribution, sort of normal distribution plot. Let us superimpose this, but for that we'll use the lines command. Let me first create this distribution, then I'll use the lines command to create the density plot of this normal distribution. Again, line width of 2 and color black. So this would be an appropriate plot, and we can see here the graph is given to us here. We can zoom it, it will appear like this. Now please note, I'm going to plot 4 plots, and so for that I need to have 4 plotting windows. So with this rmfro argument, we have 4 plotting windows. Next I'll add another plot which is superimpose Nifty with normal. So we'll superimpose Nifty with normal. I'll not retype the code, I'll simply use the same plot, only that I'll change the color and name. So here I'll change the name Amazon to Nifty. I'll change maybe a color to maybe blue color. Here I'll replace Amazon with Nifty, and then I'll again, please note that I need to change the mean also for this graph. The mean will be for Nifty and also the standard deviation for Nifty. For the next graph, I'll superimpose Google with normal. So superimpose Google with normal. Again, I'll copy paste the same plot. I'll use maybe green color here for Google. I'll change the corresponding places. I'll change the name to Google now. So instead of Nifty, I'll use Google. And the mean and standard deviation also I need to change to Google. The last one. So the last one is Apple. So we'll superimpose and again we'll copy paste the code. So here now all I need to do is replace this Google with Apple, and instead of green probably I'll use the yellow color. So instead of Google we are using Apple. For mean and standard deviation also I need to ensure that I change this ticker to Apple, and we are done. So now we start with the original first line where we'll ensure that there are 4 plotting windows. First we'll plot the density plot of returns of Amazon, then add the normal distribution to it, lines, then again the density plot of Nifty, then normal distribution, lines, and so on. So we'll keep on running these codes, and within a few seconds maybe we'll get all the 4 plots. Let me zoom them. So once it is done, yes, now I can zoom it. So you can see now a nicely plotted 4 plots. Here we can see on the all 4 plots, we can see Amazon, we can see Google, normal, and so on. So it's a nice plot with all 4 plots density plot compared. As we can see, compared to normal, all of them are higher peakness. We can see the peaks are higher, and hopefully we understand from financial market properties that tails would be fatter. While here we cannot see the tail area, in the next video we'll try to focus on the tail of the distribution and see whether the tails are actually more fatter or not as prescribed in the financial markets behavior. So in the previous video we compared the distribution of returns to the normal distribution. In this video we'll compare the tail region. Earlier we couldn't focus on the tail region, so in this video the focus will be on lower tails, particularly the negative tails, because investors are more sensitive to negative tails, that is extremely negative returns. Again the same par and fro to create 2 cross 2 4 windows. Next the density plot, and again we'll use the same plot. So I need not write it everything again. What I'll do is I'll make use of the previous command. I'll make a small adjustment. I will notice what I'll do is, let me show you. So what I'll do is I'll restrict the X limit. So first let me restrict the X, and there is a very simple way to do it. All I need to do is use this xlim command. This will ensure that the plot is restricted to a certain X range, which is minus 0.001 to 0.2, and let's see if it works. First let us, okay, so if I recreate the plot, use xlim equal to C, and I'll run this. Let's see if it works. So yep, okay, so I should have given the negative values. So now it should work. Yeah, now we can see that the negative values are given, and we can nicely see how the tails are slightly fatter and over and above the this thing on the extreme values are slightly higher in the red curve than the black one. So similarly, all I need to do, I'll add the same X range in all the plots. It's quite simple. So I'll just add the same here first. Similarly, I'll add the same here, third, first, second, third, and lastly the fourth plot. So I've added a specific range on the fourth plot. So let's see, we'll plot all four of them and see how the tail behavior looks. So we'll superimpose on the normal with particular focus on tail behavior. We'll zoom onto it. Let me zoom it. Okay, so notice all these plots, and you would find that on the extreme tail region, as we reach the extreme tail around extreme values like -5% return, you notice that the returns of the stocks are slightly crossing and going above board to the black curve. See, it is here down and then suddenly it goes above, which indicates that tails are indeed fatter. So we have excess peakness as well as fatter tails, which is often referred to as kurtosis, the kurtosis behavior, excess kurtosis. Normal distribution has a kurtosis of 3, and it is said that stock returns are distributed with a kurtosis higher than 3. So they have excess peak nature and as well as fatter tails. Now in the next set of videos, we'll understand how to compute the cumulative returns, or what we call create the index out of return. In this video, we'll do a very interesting analysis. We'll convert the returns into cumulative returns, or what we call create index of returns. And then we'll see a $1 invested in 2010, how it converts into 2020. So for that, first let's start with a simple command par mflow to set one plotting window. In this plot, we'll superimpose all the plots. So one plotting window rather than floor, which will be done by this command. Next, let us create index. So in the closing dollar, let's call this Amazon index variable, and this index variable is nothing but it's closing dollar Amazon close divided by closing dollar Amazon close, and we'll divide it by the first value. So I'll also define that these are numeric variables. So s dot with s dot numeric, I'll specify that this is a numeric series, so that this ratio commands works well. So I'll run this. Similarly, in the next set, I'll create Nifty index. I'll place this Nifty. Similarly here, I'll replace it with Nifty, and here also I'll use the Nifty. Next we have Google. Lastly, we'll have Apple. So this is Apple. So now my index variables are ready. Let us add them into a data frame variable called closing underscore ds. So closing data frame, which will carry all the information in the data frame form. As you can see, the variable is created. Next, we'll also add a date variable to this data frame. So for that, I'll simply add this date variable, which is as dot date. index of closing. So let me check what we have now inside head closing. So we have added the date variable as well. So we are good. So now let us start with the plotting of cumulative returns. How to do it? Plot x equal to closing df dollar date and y-axis we have closing df dollar Amazon index. We'll use line type. We'll use xlab equal to date and ylab equal to value of investment in dollars. Let us add a color black. We'll use different color for different stocks. Line type of 1 but a line width of 2, so it looks slightly more darker, more thick. Now let us add the central heading main, which is value of $1 investment in Amazon, Nifty, Google and Apple from December 31st 2010 to December 31st 2020. So this is our heading. Let's see. Yep, the plot is there. We'll come back to the plot, but let's add the other stocks with the lines command. So we'll use the lines command to add other stocks. So let's start with the Nifty. So we'll use the lines command where x equal to closing. Again, closing df. We'll add the date. We'll add the y-axis as closing df dollar Nifty index. We'll add the Nifty index. And again, the same set of commands. We'll use type equal to line, but we'll change the color to red. We'll use a red color. Then line type equal to 2. So we are slightly modifying the line type. You'll see in the graph how it appears. And line width remains the same, which is 2. So we'll add this. Next, we'll also add some other indices. For example, in addition to Nifty, we'll add Google index, and we'll change the color for Google to maybe green. Let's see if we can add green and line type. So again, line type 3, and the last one we have is Apple. So we'll add the Apple plot here. Apple. We'll add the color to black, maybe blue, probably blue. Last, we'll add the line corresponding to initial investment of $1, which is the AB line. So we'll specify the parameters inside AB line, that is height equal to 1. So we'll put a height equal to 1 with the line type of 1, LTY line type equal to 1, and line width 2 but color equal to black. So let's see how it appears. So it's there, or because we have already plotted a black in the beginning, so let me make it yellow. So it's there. So now this is AB line. Now we'll add the legend so that our plot looks nice. So let's add the legend. We'll consolidate all these things. So let's add the legend. So for the legend, we have some empty area on the top left. So we'll add the legend on the top left side. Then we need to specify the tickers, which is Amazon, Nifty, Google, Apple. Next we'll add the color as starting with, will have to be consistent, so first black, the same way we have given to the stock cumulative line, so black, then red, then green, then blue. Now we'll specify the line types, which we have added as 1 2 3 4. So I'll use the 4. I need to add the line type, so LTY equal to C 1 2 3 4, and line width I have already used as 2, so I'll use the line width as 1 2 sorry 2 2 2 2. And lastly the fill, so fill also have to be consistent, so fill equal to C, and I'll use the same colors copied from here. And now let's enlarge the plot window so we can plot a nice plot. We'll start from here. So first we'll plot the main plot, then the lines, first, second, third, and then the horizontal $1 line, and lastly the legend. So very nice plot. We can see the Amazon. We can see Amazon has given the highest returns, highest bang for the buck, and then Nifty, Google, Apple. We can see the plots. We can zoom it also. You can zoom it here. You can have a look at it, or you can save it, export it as image. You can change the shape and all sort of things you can do here. You can also, for example, export it to PDF and so on. So now that we have examined the data very carefully, visualized it, we'll move on to technical analysis, starting with the moving average indicators in the next video. In this video, we'll start with the moving average analysis. It's a very important and fundamental technical indicator. Start with moving average analysis. First, we'll remove any not available observations in our closing data. So we'll use this na.omit to clean our closing data. Next, we'll create rolling average series for, let's say, moving average for 50 days. For analysis purposes, we'll use simple moving averages. For others, exponential and others, you can refer to the videos for explanation. The application is identical. So we'll use the rolling mean, this rolling mean R command, and as a first step I'll use closing $Amazon close prices, and we'll use for 50 days, so that this is the first indicator for 50 days. Similarly, we'll choose other, or rather create other indicators for 200 and 500 dates. So now that we have created the 3 indicators, let us bind them in a single data frame called Amazon. Let's give it a name, moving average MA, and we'll use the C bind with zoo wrapper inside, and we'll use closing $Amazon close price. We'll add the 3 series that we have created. First, Amazon moving 50, then Amazon moving 200, then Amazon moving 500. So these are all the series. Also, because initially observations have been used in creating the moving average, we need to again remove the non-available observations. So Amazon MA equal to na.omit, with the Amazon underscore MA. So with this, I think our data is ready. So let's check Amazon MA. If there are all the desired series. Yes, we have the closing price. We have 50, 200 and 500 days. In the next step, we'll plot the moving average series that we have just created. So first, I'll set up the plotting region by par m fro equal to 6 c only, so that one plot is there. Next, we'll use this plot command and we'll specify that x is index. So this will have the dates Amazon MA. So this variable index Amazon MA will carry the dates. We'll name the x-axis x lab equal to date. The next y-axis, so we'll specify that y-axis is the closing prices, and we'll put that y lab equal to price in dollars. We'll also specify that type equal to line and color equal to black, and we'll provide central heading main as Amazon simple moving average. We'll also add or specify that's January 1st 2014 to December 31st. You can choose any date to plot and select depending upon your data. So December 31st, let's say this was our date period that we wanted to specify on the heading. You can choose any date or select the data accordingly. So this is our first step. Now if we have done everything right, you can check just by plotting it. If your plot is there, yes, it is plotting. Now let's add line by line. We'll add the moving average plots. So we need to ensure that we have put the plus symbol here so that it takes the next line. So we'll use the lines command. In the lines command, you need to again specify the date, which is x. The same command I'll use x equal to index Amazon MA. But now for y, we have to specify that it's Amazon MA $50. First the 50. Let's give it some color equal to red and a line width of 2. Similarly, I will also add other moving averages. So next would be, the date will remain same. Next would be 200. Let's give it a color green. And another one is 500, and let's give the color as blue. We may also change the line type as well. Maybe we'll put a line type argument here. LTY equal to 2, LTY equal to 3, LTY equal to 4, and let's see if we have done everything right. Let's start plotting them one by one. So note this. So as you can see in this plot, the most fluctuating line is the black one, which is the original closing prices, which is very noisy. And as we keep on increasing the period from 50 red to green, 200, then 500, the plot becomes smoother and smoother. And then this, as the more fluctuating lines, for example, black line touches here and then again changes the direction. So the trend and reversal signals are generated as the more fluctuating line quickly switches the direction by crossing from above or below the slower line, which is the moving average lines. The strength of the indicator depends upon how longer duration line has been crossed from upper or lower side. For all these discussions, you can again refer to the lectures, the theoretical discussion videos. One more thing we can do here is to add the legend. So we can add the legend here. Top left seems to be empty side, so we'll add on the top left. Also, I can add the headings. For example, I can put Amazon price, first closing price. First series is the closing price. Next is 50-day MA. Next is 200-day MA. Next is 500-day MA. Now that we have provided these arguments, we can also add line type as equal to C1, 2, 3 and 4. So we are done with this. We can also have specified the line width as C. All of them are 2 only, so it's fine. The next argument is the color. So we can use the same. For color, we can use the same. So see, so the color is black, red, green and blue. So these are the colors, and we can specify the fill as well. So fill with same colors. So it's a nice looking legend that we are going to add here. So as you'll notice, as you can see here, now the legend is as it. There's one more way, easier way to plot this. There's something called chart series plot. Without putting so much effort, you can make use of chart series plot that is available, which is part of quant mode package. We have installed the quant mode package for this very reason. Notice how easily I'll plot such a nice plot. I'll provide the closing, then I'll give the name as equal to Amazon closing price. Maybe I'll use a white theme, and here what I'll do is I'll just put this simple command to add a SMA lines. So I'll add this add SMA, and all I need to provide is specify the duration. So for example, I specify 50, 200 and 500. So that way I'll easily specify the durations. Let's plot it. So you have a very nice plot here with SMA lines, and here you can zoom also. For example, you want to zoom on a particular duration, so you can zoom, just put the duration where you want to zoom and your plot will zoom in there. So I'll provide the zoom chart. So I'll see if this works. Zoom chart works. Yeah, it works. So it did. So I'll use this zoom chart, and you can see a nice plot where I've added the moving averages and all the required details are available. Very easy 2-line plot to get the same effect. In the next video, we'll discuss the Bollinger Bands.